Next talk, feel free to keep coming in. There's some seats in the front here, in the middle, on the side as well. My name's Rob Morandi. I'm a first-year MBA student here at MIT Sloan. It's my pleasure to introduce our speakers here today. We have Sasi Kupanagari, Travis McDonough, and Corey Patton. Their talk is titled Winning in Sports, and it's presented to you today by Intel. Thank you.
Morning. Who's here to talk about Intel? Let's do this. Well, I'm sure a lot of you people are seeing in your program Gail Shepard. I am not Gail Shepard. I'm Corey Patton, as he introduced. And Gail she wanted to be here to talk about how Intel's winning in sports, but she's a little sick and under the weather on the West Coast, so I'm going to play the part of Gail. I have less expensive shoes, but I think I know what I'm going to talk about. So you get me. But you don't just get me on stage today. I brought a couple of people to make me look a lot smarter. Travis McDonough is the CEO of Kinduct Technologies, and Sasi Kupanagari is a senior manager of analytics and Intel AI, and they're going to make me look a lot better today than I would otherwise. So, we're Intel, and putting a slide up there that says Intel winning in sports would have probably gotten a laugh a couple years ago, but not now. Intel, you bought chips and processors, and they weren't ever in sports, right? So I mean, I was at a Super Bowl party about a month ago, and a group of close friends, and Intel 360 replay commercial came on, the one with Tom Brady where he eats the pancake off the floor, and the guy next to me, I've known him for a long time, he goes, "God, I didn't know Intel was in sports." And I'm standing next to him, and I've got a Intel t-shirt on, and he's not invited back next year. But not knowing how deeply Intel is invested in sports, it's okay. I mean, it's okay because he knew Intel, and he knew Intel's status. He knew Intel's reputation. He knew we were cutting edge in technology, and he knew we were a stalwart in the industry. And so it's okay that he didn't know we were there yet, but we are winning in sports, and we're just getting started. And it's already working as it relates to human performance and Intel AI and professional teams. And I want to touch on a couple of ways that Intel AI is solving problems already for professional sports teams. We're maximizing an athlete's performance using machine learning. And we're mitigating risk of overtraining or potential injuries. And we're identifying talent using Saffron's advanced analytics platform on top. But let's take a step back here. What makes our sports analytics approach so different than everybody else's? We have all the pieces. We don't just collect the data. We don't just visualize the data or aggregate the data. We don't just do machine learning on top or just advanced AI or advanced reasoning with Saffron. We do it all. It's an end-to-end solution, a full-stack ecosystem able to demystify all that data and derive winning solutions for athletes, leagues, teams, all organizations. But that all starts with Intel's bedrock, hardware. Chips and sensors and devices. Think about all the inside Intel stickers you saw at all the laptops you buy. You bought them because you knew they were the best processor inside your laptop. You never bought an Intel laptop. You bought it because it was powered by Intel and because it was best in the industry. And that's where we're headed in collecting all of the data in sports. Chips that can be embeddable in a shirt or shoes or drones or uniforms or helmets or bats or gloves or whatever. And it all starts with collecting great data. So Intel looked around and said, well, man, we don't have an athlete management system that aggregates and represents and visualizes all this data. So who can we partner with? Who out there is winning in that industry, and who can we partner with? And we found a company who was dominating the market, Kinduct Technologies. And we found Travis, and Travis was a missing piece.
Thank you, Corey, and thank you, everybody, for your time today. As Corey mentioned, my name is Travis McDonough. I'm the CEO and founder of Kinduct Technologies. Essentially what we are, or who we are, we're a data aggregation, analytics, and recommendation engine specific to the health, the wellness, and the human performance markets, and we have a strong focus in on improving outcomes. The world of human performance right now is really being powered forward by three desires: to create bigger, stronger, faster athletes, to help mitigate the escalating costs of injury, and to help to identify talent at an earlier age. These three things have really powered the gestation of a brand new industry around player wealth and health and tracking. It's hard to turn on your computer without seeing a brand new data elicitation device or technology innovation that is tracking a player somehow. But unfortunately, this new market has failed to live up to expectation, and it's failed really for two main reasons. First, the data that is being emanated from these devices, it's separate, it's siloed, it's segregated. It's everywhere except where it should be, which is in one location. And second of all, the data that is being elicited is completely disconnected to the output of programs, interventions to drive better results. And that's where Conduct comes in. We are essentially a promiscuous aggregator of all the various species of data out there in the market. The CSVs, the Excel spreadsheets, the heart rate variabilities, the GPS, the rate of perceived exertion scores, electronic medical record data, bloods. It all gets put into the one platform where we can stack and visualize and aggregate that data and start to look for patterns and trends and relationships. And if there is an aberrant pattern that's detected, an alert, a trigger, a notification gets sent to somebody around the athlete or the athlete themselves to say, hey, things are going in the wrong direction. So essentially, all the data, pollution that's out there, it gets pulled into our platform where through a labyrinth of complicated technical plumbing, artificial intelligence, and sports science, out the other side comes some discernible insights. If you look at the market over the last 8 years, we've tried to stay ahead of this market because it's so ever-changing. But we started as a content company and pushed workout programs, nutrition plans, strength and conditioning recommendations, and it was starting to fall on deaf ears. Why? We didn't hit the target. We needed to learn much more about the client that we were working with. And that's when we started the ingestion process. We literally started to build the scaffolding to all kinds of these technologies and again pulled it into one spot. But the market said we need more. We can't just ingest the data. You need to be able to graphically depict it. So we built a dynamic reporting engine that allows you to pull up all the myriad of data sources where you can compare and contrast through this sort of sexy graphical depiction engine. The market wanted more, and they said, hey, we want to be able to aggregate, to rank, compare, contrast. So we built an aggregation engine. But the rest of the journey is challenging, and this market isn't going to be won by small companies like ourselves, and we had a great opportunity to partner with Intel, who have some very sophisticated artificial intelligence infrastructure and machinery that are really helping to change the industry. So we pass all these giant data sources that we have through the artificial intelligence that are stitched into our technical membrane to figure out these very actionable and discernible insights. There's still another corner to turn in this market, and that is to connect these insights back to the content layer to be able to push out targeted and specific programs, all to drive the results that are needed. But for us, again, a small company from Nova Scotia, to partner with Intel meant a whole bunch of different things. It meant being able to connect with an organization that is involved in the innards of a lot of the data elicitation devices out there. So they're the mechanical viscera inside these devices. It meant that they helped us with security. It meant that they helped us with permission-based authentication, because our system is built that the athlete sees their information and only their information that could be specific and special to them that they don't want to share with people in their team or in their league. It meant that they helped us with artificial intelligence, and that's really why we're here today, to talk about those artificial intelligence engines. So these specific projects, that we're working on that Sasi will go into in great detail, they are unique. This is not just us looking at XY tracking data. That's one of multiple data sets that are driving the insights in this project. We're stacking on top of XY data anthropometric measurements and fitness testing and practice loads and blood measurements and all the other information out there that is captured off the athlete. That's what's going to change the industry, and we're unearthing these patterns, these trends, and these correlations that literally we have never seen before, so it's very, very exciting. I think it's also unique that we're doing these projects not just in one sport and not in one position, but we're working with the athlete, with teams across the big 5 sports to really help to change the narrative around this. Before I pass it over to Sasi where he can go into more detail, I do want to say that it's important we don't stand up here and say that, hey, we have a genie in a bottle. This is a black box that can tell you all the answers, because what we do will never replace the importance of the human intervention, the relationship that a strength and conditioning coach or an athletic trainer or physical therapist has with their athlete. This will never replace the team culture and the importance of team culture. But what this will do is arm the professional that works with the athlete with the best informed decision-making capabilities to get the best outcomes possible. So I'm going to stop talking because I have a tendency to do that. I'm going to hand it over to Sasi so he can go into some more specifics about this project and some of the exciting stuff that we're doing with Intel. Thank you.
Thank you. The clicker's up there. You may go 2 slides ahead.
Oh, sorry. No worries. Hi, I'm Sasi. I manage analytics and AI at Intel. I'm part of the data center group. All the processing that happens in the cloud, bare metal servers. Thank you, Travis. I may not be going in great details because Intel legal only allowed us to talk so much. So lawyers, you can't live with them, you can't live without them. So I will try to keep it at a high level, and any questions we try to answer as much as we can, okay? So I would be talking about Trusted Analytics Platform, TAP, what it is about, and also talk about a use case that we work in partnership with Kinect. TAP is an open source cloud native big data platform. What does that mean is you can start building machine learning and deep learning applications on TAP within a matter of a couple of hours. Traditionally, to do this, you need an army of guys from infrastructure, from networking, from middleware, from database, and all those folks. Bare metals, upfront cost, and integrate all these technologies together. We do that for you. It's open source. You can go to GitHub and download it, but it'll be only a platform as a service. So as we start working in sports, we primarily see there are 3 main requirements if you want to be really successfully start selling analytical software, analytical solutions to teams or leagues. One is cost. You know, most of the teams, not all, but would love to spend their money for the players, and then coaches, GMs, front office, keeping up the lights and paying the groundmen for their Christmas party, and whatever is left bottom, they try to spend it on analytics. So cost is very important. We need to have lower cost. Second one, it has to be simple and faster time to market. And the third one is it has to be performance. TAP is open source. It cannot be lower than that, but if you only use it as a platform service. But we also do software as a service, ready solutions, and also provide the platform if you want to build your secret risk base. It is deployable across hybrid clouds. It can run on public clouds, bare metals, interoperable. It's distributed, build applications on Dockers, manage it through Kubernetes. So you can start small, you can scale it up, scale it down based on however your workloads are going. If you're in the season, if you're running most of the workloads, you can scale up and pay the cost, and off season, you can get it down. Second one is simple and faster time to market. What does that mean? Is it provides a data science collaborative platform where data scientists and app developers or coaches, everybody in the organization can work together in a collaborative fashion and able to share the training models and get faster time to market deploying these solutions. And the third one is performance. At Intel, we pride building up vertically integrated solutions, Silica up. We are a semi-chip company, and we have the world's best technology. And if you look into the server market, we own a good chunk of the server market, majority, almost. So what we do in the data center group is we take these algorithms and we integrate them to the math kernel libraries on the Intel Silica. So the performance you get running your workloads on this vertical solution, you can't beat them in the market. It is, that's why we call it winning in sports. Your workloads on performance cannot have any other stack that's running on these machine learning algorithms. So given these three needs, we are partnering with Kinect. I know in the room everybody knows Intel. If some of you don't know Kinect, you really need to connect with Travis. He's a great guy. He's a visionary, and as a person, he's a pretty awesome guy to talk with. So we partner with Kinect. They're a data aggregation company. They have the data from the leagues, from the teams, from the coaches, everywhere. They also manage the quality of the data, provide data dictionary and all the aspects of it. So they are so ready to use. So we work on a use case with them to accurately predict the athletic performance management. And one of the use cases is, hey, how do we predict mechanical loads and physical loads for the upcoming games? As traditionally, coaches use heuristic models just to do the assessment. This is a heuristic-free model using machine learning supervised algorithms that we have run on tap. This is a very standardized data science workflow. Most of you should be knowing. You do train the models, and you start running scoring for ad hoc streamings. So what we did on tap is we got the data from Kinect. Sports, unlike other industry, if you look at Amazon or Netflix, when they start building their recommendation engine model, it is pretty set. They start testing it and inferencing it, and they continue to do it. They do model updates now and then. But sports data is very different. If you build a model based on last season's data, and you want to continue to inference that model this season, it doesn't work. Even within the season too, at the start of the season, whatever your data is getting, your model needs to continuously get trained, cataloged, and tuned. And all this operational cost in the tap, we have auto-tuning and automation, all those things included. And also I need to mention Alex from Cloudera is over here. Tap runs Cloudera distribution for Hadoop, which is optimized on Intel architecture. So we ingest the data from Kinect onto the platform. And the data scientists work on the analytics toolkit, building models, and once they are done with fabulous job, they push it to the scoring engine. And from Kinect, we start getting data in a distributed messaging format. It runs to the scoring engine, and we provide insights directly to the app. And this is a mock-up of the dashboard that the coaches see. If you see, it doesn't have teams or players' name. It's just that's what legal said we can show, so we are showing that. So what do we have is like when the coaches come here, they see that, hey, I'm the strength conditioning coach. When they work with the assistant coaches, they would be saying that, hey, these are the players. This is how their loads have been for the previous 4 weeks or 2 weeks. We use a pretty standardized rolling window technique, getting the data, that's how, and predict for the next 7 days or 14 days sliders. We use machine learning algorithms, and it is as I said, I'm going to keep it very generic, but it's no secret that to do predictions, they are like you either use random forest or some of those algorithms. But we use distributed flavors of that so that we can run the workloads distributed either on cloud or on our bare metals. So we get this data from Kinect, we do the predictions, and this helps the coaches to manage their players' playing time, how do they manage their recovery, or do they give them rest? As Travis said, that this is not a genie box that it will replace these things, but it will greatly help them to validate and also help them inform how they need to go and plan for the players' peak performance through the rest of the season. And once we have it, Kinect consumes it, and Kinect has an athletic management system which the teams are already well used to it, and as part of that, they have these offerings to look at these things. There is another part of it is, these are supervised models and everything that we have building on it, but there is another piece to the puzzle is what do we do with something like a reason-based associative AI kind of a solutions. And for that, we have Saffron and to Corey.
All right, I'm back. Working with athletes to predict peak performance is just kind of one part of it. I think in order to have peak performance of athletes, you really need to be able to identify athletes. And talent identification is somewhere where Saffron and does that part of the Intel stack really will work. I don't know if you're familiar with Saffron. This is kind of my spot. But it goes a little bit of something like this. In layman's terms, Saffron is an associative reasoning solution that uses associative memories technologies to recognize things like similarities and automatically classify data and detect anomalies in that data and recommend next best actions to do when you find things in that data. And that's important. And all this is done a lot like your brain works. So have I seen this data before? In what context have I seen this? What does it remind me of? And what did I do with that data? Your brain does that constantly with everything that you do, everyone you meet, every person you talk to, everything you learn. And Saffron tries to work in that same realm. So it's kind of important. In sports, we've been working with an Major League Baseball team for talent identification. And they came to us and they said, we kind of like what you're doing. We have a problem. We'd love to solve it with your solution. They wanted to figure out how to better get information for their upcoming draft and how to use an AI component to bring together all these scouting reports. Tons of scouts, tons of scouting materials, scouting reports, individual analysis, evaluations, front office commentary. And they said, can you bring that stuff in? It's a mixture of unstructured and structured data, and maybe you can bring that together and find similarities in there or players that maybe were hidden in there that we couldn't have found because we rely on these scouts to just tell us who to draft and who they recommend, and sometimes there's biases in there. So think about this. You got 40 rounds in the baseball draft, and you got a ton of players each year. All of these reports lived in the scout silos, and when you wanted to go draft players, you had to kind of sift through it and hope you selected correctly. So what we did was we created a Saffron memory base of all those data sources by employing NLP and parsers, and then we unified all that data at the entity level, the sentence structure data, the people, place, thing, where, time, school, all that type of things. They became individual memories. So the memories then were created for the athletes and the positions and the scouts that are all in this data set. And Saffron does that kind of automatically. And once you have that in Saffron and stored as memories, where everything and every attribute we know about that individual player is stored as a memory, you can do some pretty wild things on top of it. We have these things at Saffron called thought processes. And they try to mimic certain little functions like show me similar, automatically classify, show me anomalous things. And they're kind of tethered algorithms that work together on top of this stored solution of associative memories, and they can find things and represent them using the entire signature of an athlete, of a scouting report. Sometimes we have scouts that have scouted the same player multiple times. You have, at that point, multiple data points in that one player's memory, and it just keeps building. There's no re-ingestion, there's no stop for that. You just start building onto that player's memory. So, how is that important when it comes to drafting? Imagine you're prepping for this draft, and you have a player you just love. But Saffron, you go to it and you say, show me other players that are similar across all these scouting reports and all this information we brought together. Well, Saffron will take the signature of that player you're looking at, go through every single memory of every player in that database and say, who looks similar to this player using every attribute we know and a distance function to show how close and how relatable that person is to the individual player that you're querying. So when you come, that's important. So you say, well, maybe I want this, I'm looking at this first player. There are 5 other players I never even looked at in the data, but Saffron's saying they're kind of similar to this player. Maybe I can pick them up in a later round. Maybe they're a greater value. Maybe I just never even thought to look at this player, and I'm going to go dig deeper on that. So it's kind of a helping hand in that regard. And now let's take it a little bit further. Now say you have historical data, previous draft classes ingested. What did all these draft picks you drafted, what did they do? Where did they turn out? Were they unsigned? Were they signed? Are they stellar stars now? Did they move through the organization? Did we hit or did we miss? So now you can look at a current player that you're looking at and say, show me similar players in previous drafts that look like this player. And it's going to show you all these players that perhaps you looked at and you said, oh God, that guy never signed, that guy was a bust, that guy looked very similar, he washed out, or maybe that guy was amazing. And all of these signatures come together to produce a very reliable talent as it's coming through. And I'll give you one more nugget on top of that we do with this team. So if you take historical time points, once you've drafted these players and you say, well, you've got all this data on minor league careers and years and years and years coming up, or high school careers, or however you're tracking these players and have all this data, Saffron can do something called convergence and emergence. So if you're looking at a current star that you've got on your squad and you say, show me players that are emerging and converging to look like this player, we'll take this player, the current player's snapshot of what they look like several years ago when they were in the position of that emerging star, and snapshot time frame similarities showing, yeah, here are players in all of your data that are beginning to look like the player that you've got in your squad, and you can start to see emerging talent that way. And that's kind of a cool function of Saffron on top of data, especially when it comes to talent ID. Now just imagine when you have more information than just the trainer's logs and notes and stuff that we have, and when you start bringing in, as it's moving that way, all the sensor data and all the data that's being collected on these youth athletes as they're coming up, and you're going to start to need some sort of a AI component on top like Saffron to make sense of those people. And the cool thing about it is, as I said, it's all model free. There's no training log, you don't have to train the model, you don't have to retrain it. It's just at query time, we take the memories and we look at all the memories and we say, what can we do with all this associative memory technology? So year after year, you don't have to re-ingest or reset it up. You just add more information as you learn it. And it all ties back to Intel's end-to-end human performance story, from collection to aggregation to analytics to reasoning and to Saffron AI on top. And Intel is truly winning in sports. The human performance story, it's really just being written. And I want to leave you with this. It's important that in sports to have the trust of a company like Intel, because every year you come here and you see companies that aren't here, the ones that are here last year, some of them aren't here this year. And some of them that are here this year won't be here next year. Intel's not one of those companies. We're already winning, we've been around forever, and we're really just getting started. Stay tuned. We have any questions? Yes?
So how much of this is like pilot versus like in market? How much are you testing and iterating to kind of figure out more templatized versus bespoke solutions?
Well, some of those things have to do with Intel legal, but there are current ongoing programs with teams. So. And
Kinect has partnership with over 70 teams / leagues.
Yeah, close to 100 now.
Close to 100 now. They're growing fast. Okay?
Yeah, Kinduct can speak to that.
And they keep working continuously with the teams, with the coaches and everything, and what all we build keeps discussed with them and keep moving forward. Yes? Can you come again, please?
Saffron is, right now, we're employing it mostly in baseball, but obviously we're talking to teams here and there, yes.
Okay. Any more? If not, good. Thank you. Thank you.
Hey.
Snuck in a shout out.
Classic, thank you. Ian. I'll be introducing you. My name is Fabian. Ian? Fabian.
Andy, nice to meet you.
Andy. Great to meet you. Thank you for coming.
No, thank you.
How have y'all enjoyed the conference so far?
Very good, thank you, yeah.